Okay, come on, I know what you're thinking, right? And it's not clickbait. I mean, who's really going to watch a road to Pupil? Well, here's the situation. I currently am a qualified noob on Codeforces. I would have really wanted to see a video of someone starting from the ground up, but that wasn't the case. And hopefully this video, or this series of videos, will help sort of show people that you don't need to start at Candidate Master. There's a whole journey that has to take place from the bottom. And hopefully you can see that here. So with that said, okay, so the format of this will be to first go over what we aim to have done that week, what we actually did, what we learned, and what we're going to do next week. So just for some context, the last time I was programming, it was about a month ago. We were at like a national competition, and then that was that. It was about a month ago, and up to this point, I've had finals that only ended on Wednesday. So programming started on Thursday for me. So in those days from Thursday to today, which is Sunday, my aim was to do 4 CF problems at 1300 to 1500. And I also noticed that there was a round taking place, a Div 2 round. A few things that happened. So I only managed to solve 5 problems. Okay, so I'll explain what happened with that. But I'll go over the problems that happened. They were fairly modest, like the 15, 13, and 1400, and then these 2 contest problems, the Devon problems, the dreaded Devons. Okay, I'll get going with this one. Permutation partitions was pretty straightforward. From what I recall, I AC'd it on first go. I guess it was interesting. I'm not fond of the partition problems where we have to find segments of the sorts. I am slow to catch on to those tricks, but I'm happy to have got this problem fairly quickly. I've got the code right here. I'm going to quickly zip through it. Okay, so we wanted to find the number of different segments we could make such that the max sum in each segment would return, or rather each of the possible segments would return some possible max value, and there were more than one ways of getting that max value. So this seemed to do it for me. So say for instance, we had elements in a list that went up to 8, and I told you that I wanted to split it into 3 partitions. Well, then obviously I would have 6, 7, and 8 all in 3 different segments to ensure that I get the maximum output of the sum of those values of 21. Please be 21, please. Okay. So I just find the position of those and then use a bit of combinations to get the sum of all the different left and right pointers I could make for each critical element, if I could say. I'm scoping out Web of Lies, but I won't look at it right now. The next problem was a lovely maximum width. Okay, I'll wait a little bit for that one. Okay, that one took me some time. But accidental victory was cool. Okay. If I remember correctly, this was just a probability problem, really. It wasn't horribly bad. I remember getting this one in 3 goes. Oh yes, I was pretty happy with this one because I needed, if I look through this briefly, there were a handful of tests, and I needed to, almost in a way, oh, I remember now. Okay. So we had different players with different amount of tokens, and then essentially we had to play it so that if a particular token was to win all of its games, and how you would win a game is if you're drawn with another player that has a token smaller than yours, you'd get the sum of your tokens together. You'd also win by this random case where if you're drawn with a player with the same number of tokens as you, you'd also get their tokens but randomly. But with a random by random, well, no, what am I saying? I'm saying that there would be a possibility that you get their points. So you just assume that you do for the sake of probability, because we wanted to find out how many players have a chance of winning. So how many have a 0% chance of winning? That's essentially what I'm searching for. And then just return the difference. So I used a few maps, well, a single map anyway, and I started from the top, so the player with the most likelihood to win, and then I'd iteratively go down until I found one that didn't, and then as soon as I found one that didn't, I break there, because I know no one else before that would have a chance either. I was pretty happy with this one. It was a 2-second time limit, but my submission, if I remember correctly, was around 200. Yeah, 280 milliseconds with Java, so that was wonderful. At least, at least I think anyway. Okay, so maximum width. Now here's where I was being horribly dumb, because this problem was dead simple if you just sat there for a little bit. They give you two strings, a source and a target. Okay, I won't call them a source and a target, but we have two strings here. I'll zoom in quickly just for your own convenience and my own. But given these two strings, we want to find this target sequence. We want to make this string from indices in this string. So we'd, for instance, match these two A's together, match these two B's together, match those two C's. And the maximum width, which is what we're searching for, is the maximum difference between two adjacent indices of the target sequence. So in this case, it would be 0 to 1 to 3. So that 3 to 1 difference is max. No, it's not 3. This is 5. Sorry, this is 4. Sorry, this 4 to 1 difference is 3. We go through that, right? But here's where I sort of killed myself with this problem. I didn't know how to deal with this case, so I thought of it like this. Immediately my head went to, okay, what if I have duplicate letters that are like situated next to each other? And then I didn't know how I would treat the case of, oh, should I pair this B with that B, and then should I just automatically pair this B with that B? But then I wouldn't know how many B's would be after that. So would I have to assume that I picked the first one here? Do I pick the last one? Do I have to know how many of a particular letter are in some sequence, or how many B's do I have to make that choice? Well, I was being dumb, or I was trying to be too clever, if anything. And really all that I needed to do was, after getting some help, of course, it gets like that when you're when you're a newbie. But all that I had to do was run an iterative loop where I match each letter with the first occurrence, so the leftmost occurrence, and then do the same thing, but then favor the right, so get the rightmost occurrence, and then find the max difference between the two different routes. So what's the max difference if I had gone left? What's the max difference if I had gone right? Get the max of those two, and that will always be your maximum width. And this was just a greedy problem. At least you know what? At least it might hit me one day. But this was tagged as a binary search, and I don't know how. I don't know how you do it with binary search, but we use greedy and of course 2 pointers. Now what I'm most scared to tell you about. Well, I did round 757, and it was bad. It was really bad. I don't even know where I am on the list. Okay, there I am. Okay, well, right there, we only solved A. It was a routine binary search, and it took me 11 minutes. It might not even, I don't even think I would have needed to, but here's where we died. Wrong answer on pretest 4 7 times. I dropped thousands of positions down this list because of that problem B. Problem C was some bit masking solution, I think. Not bit masking problem, some bit manipulation problem. I don't know if I had to use masks, but yeah, I don't have much else to say. It was horrible. I did not enjoy B until I realized that the difference between me getting the pretest and not getting the pretest was the following. If I could just find it here, I think I have to navigate to that folder now. But yeah, it stunk. It really did. Well, I wrote this out. I was pretty happy with it. I understood the problem quickly. I wrote out the solution, but I was getting fails on pretest. I believe I don't have it on this laptop. The submission, it involved me just changing the data types of these values. So push and pause needed to become long. And up to this point, I don't understand how the values would have even become that big, but changing it to long would have meant solving the problem for me. So I was very mad. I am yet to look at C. I was very sad, but I need to upsolve that, and that would seem to do the trick for me. I was pretty happy with it though. Happy I did the contest anyway. Sure, it didn't go my way, but many of them won't at this level anyway. Okay, so I'll quickly go over what I'm planning to get done this week, and here they are. So the plan is to do problem-specific practice, more particularly bit manipulation, because I am crap scared of it. I don't want to see it in contests, and I know if I see a bit manipulation problem, I lose hope, and it's quite sad. Not far on that list is strings, so we'll have to do strings right after that, and then DP and so on. There's a lot of branches that we can explore. But second to that, we need to be pushing our problems, our reflections, what we've learned to an Excel sheet, because that will be beneficial in the long run, especially for repeating problems and so on, techniques and tricks and issues that I might come across again and again and again. Then there's a lack of contests this week, especially Codeforces rounds. I might just do 2 virtual contests and an edu round. There's an educational round. I think it's Div 2 as well. Yes, it is Div 2. Well, I didn't need to say that, I thought. Next. 6 problems from the CF problem set, also at greater than 13, maybe 1400. And lastly, this kind of stinks, but our unsolved list is horrible. I'll just quickly show you. There's some really poor problems on here, and I should very quickly take them off my list before it gets even bigger. But yeah, they need to go quite fast. I think that'll be that. I might just include a clip of me celebrating. Way! Good job. Dad! Come on! Yeah, and it was pretty fast. Wonderful news, wonderful news. It's a beautiful day. It's a beautiful day.